equal to exp minus exp minus x is flow, minus mu divided by beta. So look at this instruction. This is something which is nothing else than the formula of the Gamma distribution. But x is not a single value. It's a vector. Flow is a vector of observations. And therefore R delivers to you back a vector as well. And the vector contains the probabilities for each of the observations contained in the vector flow. So basically in R, when you compute an expression on a variable, the result just refers to the variable. If you compute the same expression on a vector, R automatically applies the expression to all the elements of the vectors and gives back to you a vector of results. This is very handy because you avoid the copy and paste that we have to make in Excel. Now let's see the results, if they are meaningful. I would say they are. They are similar to the results that we found in Excel. Now let me compute the statistics, the Kolmogorov-Smirnov statistic. So Ks is equal to what? It's the maximum of the absolute value of G prop minus F flow. In this way as well, I am condensing in just one instruction the computation of the difference, the computation of the absolute value, and the computation of the maximum. Here there is something that doesn't work. Sorry, one second. One second. I made the check and I saw that something is not working. It's the number here, number 7. No, sorry, I didn't order, the mistake that I made here, I needed to order the vector of the river flows. Okay, so basically sort. Because otherwise they cannot be compared. And then again Ks, and then it should be 0.1. Perfect. You see the importance of checking. Okay. Please try to see the difference between what we did in Excel and what we did here. The difference in terms of operational difference. So you may say that R is more complicated because you don't see what you're doing. In Excel, instead, you continuously see the data and everything. But I would say that this is faster. And once that you know the exercise, if you try to repeat it in Excel and repeat in R and take the time, I would say that this is faster. And you may say, but the difference in timing is negligible. But let's suppose that there is a difference in timing of 5 minutes. So a difference of 5 minutes in something that took half an hour to be done. Basically, you may say it's negligible, it doesn't matter really. If I take half an hour to make the computation of 35 minutes, it doesn't make any difference to me. But keep in mind that in a working day, you usually work 8 hours. So you have 16 half an hours. And therefore, if you save 5 minutes 16 times, you save exactly 1 hour, 20 minutes, if I'm not wrong. So at the end of the day, you don't work 8 hours, but you work 6 hours and 40 minutes. And you have 1 hour and 20 minutes to go out and take a drink, or to make jogging, or whatever. It makes a big difference. So saving 5 minutes over half an hour, it makes a big difference. And if you are a professional, the most important quality that you have to ensure to your clients is timeliness. This is the most important thing, or let me say, one of the most important. Of course, it is also important rigor, it's also important the care with which you present the results, but let me say that timeliness is really a sign of, of commitment, of high quality. And you can't be timely if you are not efficient, because on the job market you compete with other people, and basically if they are more efficient than you, they are more timely. And therefore it's extremely important that you really pay attention. Your mission is to work well, to make a good job, and to make it very quickly. This is the mission. And it's important that you pay attention to how to reach this target. It's possible, it's possible to work, to make a good job with a very timely approach. It's possible. But of course we need to make an effort to learn how to do it. So for this reason it's extremely important that you know how to use the PC, because this is our working tool, and if you know several different methods for getting to target, you can select the most efficient one. In this case, I would say that R, it is more efficient, but you may try. Now, we have something more than 5 minutes. I want to propose to you an homework that you may skip if you want. And the homework is to make the same exercise, the same application by using real data. And next week, as you know, I cannot teach because there are degrees on Wednesday and Thursday, and on Friday I'm not in Bologna. So we need to skip to 1 week later, so no lectures next week. And I didn't ask you if you have some free slots, because it's not a problem to skip this first week. Later on in April, you remember that there is some holes, some free weeks. In that case, I will make an attempt to save some of the lectures, because I would like, as I told you, to close by the end of May. So, what is the homework? Let me go back to my web page. And if you go in the bottom of the page, I added an homework. Oh, sorry, this is the previous one, not this one. Here. Basically, you see that I took a blank line to separate where we are from the future, and the future may change, of course. It's unpredictable. And the first exercise that I would like to propose to you after the introduction to R, which we already talked about, is peak river flow estimation for the Secchia River. So let's click on it. And you will download a zip file, if I did everything well, yes. So let me open the zip file. And there is an a PDF file. Let's look at what is required. Basically, The second is a right tributary of the following rate flows between the intermediate model. At the closure section, there is annual maxima data are available. See table 1 and the ActualSheet file, because there are 55 numbers. In order to avoid you to input the numbers one by one, I provided the numbers in an Excel file. Okay, so here there are some information on the catchment, and I provide the information for two reasons. The first is to deliver a message. You never have to estimate the peak flow for a river without getting information on the river. So another suggestion that I give to you, go to Wikipedia and look at this river, get information. And some information is here. There is a second reason for which I provide the why I provide the information, sorry. And the second reason is that later on I will ask you to estimate again the peak river flow by applying the rational formula, which you already know, but still I have to teach you how to apply it. So you can forget about the second question. So let's read. There are some information, including the parameters of the rainfall depth duration frequency curve. Probably you already know what it means, but no problem, I will tell you. Just skip that. And here it is required to compute the peak flow for a return period of 100 years. I have 55 data, the return period is 100 years. There is some extrapolation. By applying the annual maximum method and the rational formula. The rational formula later on, okay? So basically you have the numbers here. There are some, there is a gap during and soon after the Second World War. This is quite usual. In observation there is a gap usually during the war, but we can just forget about it. We have observation for 55 years, we have plenty of them. Now let me look at the Excel file. Sorry, because it is zipped, I need to copy it, perfect, and here. So in the Excel file, you just have the data. So in Excel, with the data in this way, it's quite easy for you to compute the peak flow, because you just have to redo what we did today. The only difference is that you have 55 numbers instead of 10, but there is no difference. And you will see that it's easy and the Kolmogorov-Smirnov test is passed. Then I suggest you to turn to R, and in R you have a problem, which is putting the data into R, because either you manually include the data, or, and this is what I suggest you try to learn how to input data in R through an external file. There are several possibilities. The possibility that I suggest to you, it is what I usually do, is there is no way, as far as I know, to upload the data from Excel. So, what I suggest you to make is to copy the data from Excel, paste the data in Notepad, Windows Notepad, and save the file as an ASCII file. We already talked about ASCII files, Notepad, and save it on the desktop. Okay? And basically, you will get the data into a column. I just use just one column. Forget about the years. Just the flow data, a column of numbers, without any heading. Okay, without any heading like cubic meters per second or something like that. Just a list of numbers in one column. No problem if there are gaps, white lines. Okay. And then, from R, the instruction that you have to use is this one. Flow equal to scan path file name. do it because it's already late. Basically, what you have to learn is the name of the function, scan. It allows you to scan an external file, ASCII file. And then you need to give as argument of the function the file name enclosing the path between, you see, commas. What I told you to skip any heading, this instruction, you can tell the instruction, you can tell scan to skip the heading, but it's a bit complicated. To make it simpler, just use it in this way, but it's important that there is no text in it. No text, because otherwise it gets an error. Second, important information. Be careful about the separator for the digits, for the decimals, because it may be that Excel uses a different separator than R. R uses the dot. Excel typically uses the comma. Not the comma, it's the virgule, I would say, this one. Is it comma in English? Yeah, okay, perfect. So this is extremely important because if Excel exports the data with the comma, then R gets an error because it doesn't recognize it. So my suggestion is, before you start, if you have the comma as a separator for the digits, change it in your international settings of the PC and use the dot, because this is always a trouble, because the programs like MATLAB R typically use the dot. And then if your computer is set to using the comma, it's always a trouble. So I suggest you just to change it, and then you can forget about this problem.
If you convert the Excel file to comma file,
yes,
then CSV extension,
yeah,
then text.
Yes, can be. You can also use a text replace. In the notepad, you can replace the commas with the dots automatically. This is another solution. But, my suggestion is change the setting of the PC if you don't have nothing against it, because otherwise it's always a problem. Good, thank you.